Today, we will talk about validating equality identities here. Now, the main idea here is that two expressions are equal, either coefficients are equal. Now, what this means is that for you to claim that two equations are equal to each other, what you're basically saying is that if they look exactly the same, that means that their coefficients are exactly the same. Now, what this means in actual mathematical expressions here, I think that this is one of those examples or ideas that are better explained if we just do examples. So let's just go straight to it. So now here, what we're gonna do is validate inequality identities. So it says for the following, we want to find out the values for h and k to correctly complete the identity. Now, what exactly are we trying to accomplish here? Well, here we want to say when does the left side equal the right side? That's a question we're trying to answer here. When is the left side equal to the right side? Or to be specifically, if we look at the two expressions here, the left side and the right side, for what values of h and k is the left equal to the right? Now, you notice here, they're exactly the same equations. It's something x squared plus some other number, something x squared plus some other number. So notice that they look exactly the same. The only thing that changes is that in the first equation, on the left side, we have a 3. And on the right side, we have an h. On the left side, here we have a 4. And on the right side, we have a k. So for what values of h and k are the two equations equal to each other? Well, notice that if you say that h is equal to 3 and k is equal to 4, you will say that 3x squared plus 4 is equal to hx squared, but notice what happens when h is 3. Oops. K is 4. Now, when you say that h is 3 and k is 4, now yes, the left side is exactly like the right side. So for this example, for what values of h and k is the identity equal, or is the left side equals to the right side? Well, those values are when h is 3 and k is 4. Now let's look into something more complicated, where if we look at example, oops, this should have said B, not C. Let's look at example B now. So you might notice right away that the left side does not equal the right side. Like the left side is in parentheses and the right side it just looks like an expression that has already been expanded. So what do we do in these instances? We still want to know for what values of h and what values of k is the left equal to the right. Well, I mean, right away it's not that clear. So what do we do in this case? What we do here is, well, we see that the right side, it's already expanded. So the left side is in factor form. Let's expand it and see what happens. So let's distribute this. And if you distribute, you will obtain 3x squared. That's 6x. So that's an x. And that's a 2. The right side, we're just going to rewrite it. So 3x squared plus h of x plus k. All right, so let's see, is there anything that we can simplify here? Well, I can see that I can combine these two. So now the left side is 3x squared plus 7x plus 2. Now 3x squared plus h of x plus k. All right, so notice now. All right, so it's looking better now. Now notice that the left side is almost identical like the left side. The first term is 3x squared. The first term is 3x squared. So now here on the left side, we have a 7x, but on the right side, we have an h of x. So right now we can see that h is equal to 7. On the left side, we have a plus 2, but on the right side, we have a plus k. So it's clear that k should be equal to 2. So to answer this question, for the left side to be identical like the right side, that only happens when h is equal to 7 and when k is equal to 2. Well, let's see if that's true. If we plug those in, we're going to have 3x squared plus 7x plus 2. That's equals to 3x squared. But now, let's say what happens when h is 7. So we have plus 7x plus k. Now we're saying that k is 2. So now note that the left side, it's exactly identical like the right side. So to answer the question, when h is 7 and when k is 2, we see that the identity holds. Now, here's your entrance ticket. For the following, determine the values for h and k to correctly complete the identity.